Use the data in the following table, which lists survey results from high school drivers at least 16 years of age. Assume that subjects are randomly selected from those included in the table. The table is drove when drinking alcohol. This is the first part, yes or no. And then the row is texting while driving and no texting while driving. So the first thing we want to do is first add up everything in the columns. So the yes to drinking when drove when drinking alcohol, we're going to add 698 plus 137, which gives us 835. For the no column, we're going to add up the 2,906 plus 4,347, gives us 7,253. Now we're going to add the row. So we're going to add up total row for texting while driving. 698 plus 2,906 gives us a total of 3,604. No texting while driving, 137 plus 4,347 gives us a total of 4,484. If we add the total column over here, or the total row, we're going to get the same amount, which is the entire amount that's been surveyed, which is 8,888. Now, if one of the high school drivers is randomly selected, we want to find the probability that the selected driver texted while driving and drove when drinking alcohol. So to find the probability of event A, we're going to add the number of ways event A can occur, but add in such a way that every outcome is counted only once. So the probability of event A is equal to the sum divided by the total number of outcomes in the sample space. So first let's figure out what number is that. Well, we know that drove when drinking alcohol, yes, and the driver texted while driving, so that means that the amount is 698. Now we also need to compare that to the total, which is 8,088. Now the probability that a randomly selected driver texted while driving and drove when drinking alcohol can be found by dividing the number of drivers that both drank and texted by the total number of high school drivers in the survey. So one of those who drank and drove, out of those, that drank and drove, where X is equal to 698 drivers who texted and drove, and you can see that here. Okay, so we know that that's what that result equals, and then the total number of high school drivers in this survey is N, which is equal to 8,088. Now the probability that one randomly selected high school driver texted while driving and drove when drinking alcohol is the following. Probability texted while driving and drove when drinking alcohol is X over N. We know that X is equal to 698. We know that N is 8,088. When we divide those two, we get the decimal of 0.863000692. Rounding it to 3 decimal places is 0.863. And therefore, we would say that the probability that one randomly selected high school driver texted while driving and drove when drinking alcohol is 0.863.